Introducing Thermo Calc 2025a. This release is packed with new features and functionality, including an improved ability to model microstructure in several modules, many other improvements to the AM module, a new property model library for noble metal alloys, improvements to the Precipitation module, 4 new databases, and much more. Thermo Calc Software is excited to announce that we are migrating to a new license entitlement system. The new system uses login credentials, which greatly simplifies the licensing process and brings many advantages to our customers. You can read more about the new licensing system in the release notes. Users who have a valid maintenance and support subscription will also receive an email with more information about this change. The online help receives a new look and feel in the 2025a release, as well as a reorganization of the content for easier navigation. Improvements include reorganization of the add-on modules into their own sections, new sections for getting started and what's new, enhanced search functionality, and more. Improvements to the online help are ongoing, so additional improvements can be expected in future releases. Extensive work has been done in several modules in the software to improve the ability to model microstructure, particularly for additive manufacturing. First, the AM module adds the ability to plot thermal gradients and solidification rates for both steady-state and transient simulations. Results can be plotted in 2D as a scatter plot or in 3D. The 2D plot can then be overlaid over CET plots from the General Model Library, allowing users to evaluate whether the solidified microstructure corresponds to columnar or equiaxed, given the solidification conditions in the melt pool. 2 new examples are available demonstrating these new features, one in Thermo Calc and one in TC-Python. Work has also been done to better simulate additive manufacturing in the Precipitation module and to speed up these types of simulations. Since the release of the AM module, users have been able to send probe temperature data from the AM module to the Precipitation module in order to model microstructure. However, these simulations often took a long time or failed to complete. Work has been done to address these issues and has resulted in 2 new checkboxes in the Precipitation module for non-isothermal simulations: process equilibrium data and include incipient melting. These checkboxes pre-process the required thermodynamic and kinetic data coming from the AM module in order to save time during the precipitation simulations and ensure the calculations complete successfully. One new example is available, demonstrating these new simulation options. It is now possible to predict the absorptivity of the liquid in the AM module. Previously, users had to provide the absorptivity as a constant value, but you can now choose between providing a constant value or selecting Calculated, which models the absorptivity as a function of composition, temperature, wavelength, and angle of incidence, as shown on the screen. Simulations for aluminum alloys have also been improved in the AM module. Aluminum alloys have several challenges that make accurate simulations especially challenging, particularly in the 3 areas listed. Due to these challenges, AM simulations for aluminum alloys often failed or provided inaccurate results in previous versions of the software. Therefore, work has been done to address these issues and make aluminum simulations more stable and accurate, namely 3 additions in the software. First is the absorptivity modeling that was discussed in the previous section. Second, in the AM calculator, the Smagorinsky constant can now be set by the user, whereas it was hard-coded before. This allows the simulation to better account for turbulent flows. And finally, a new setting has been added to the Scheil calculator that allows for interface scattering to be applied after Scheil. This improves the predictability of as-cast and as-printed conductivity for all alloys with large amounts of secondary phases, not just aluminum alloys. This new setting has been added to the main child calculator, as well as to the one related to the AM module. A new example is available demonstrating all of these improvements. Additional improvements to the AM module include the ability to export results in Exodus file format from the GUI, which was a much requested feature. New functionality in the plot renderer to make it easier to work with plots, and more. A new property model library for noble metal alloys is available as of this release. The library includes one model that was designed for predicting the optical properties and apparent color of noble metal alloys as a function of incident light. The model is intended to assist users in achieving an attractive color when developing noble metal alloys for the purpose of cosmetic applications. One example is available, which demonstrates 3 use cases for simulating color in the silver-gold-copper alloy system. The Noble Metal Alloys model library is available for free to all users who have or upgrade to the Noble Metal Alloys database, TC-Noble3, and who have a valid maintenance and support subscription. The Precipitation module adds the ability to convert 2-dimension or 1-dimension particle size distribution information to a 3-dimensional distribution for use in modeling. This allows users to upload experimental 2D or 1D particle size distribution data into the program, convert it to 3D distribution data, and compare the approximation with experimental data. The converse ability to convert 3D distribution to 2D distribution was added to the software in 2024a. Graphical mode example P10 has been updated to demonstrate both conversion options. A new method is implemented in the Precipitation module to split precipitate size distributions in order to identify statistics of individual populations. You can both section and split several post-processing quantities. Example P6 is updated to demonstrate this improvement, which simplifies the process and makes it more robust to identify individual populations. TC-Python also updates one example and adds one example demonstrating this. Thermo Calc 2025a includes 4 new databases, as shown on the screen. A new version of our steel and Fe alloys database, TC-Fe14, is available with this release. This is the second database to add elastic properties. It includes the elastic constants for FCC-A1, BCC-A2, and HCP-A3 phases, and can be used to calculate the elastic moduli for a single-phase microstructure. The database also improves several systems and descriptions, adds several new systems and phases, and includes many other improvements in addition to the ones listed here. A new version of our Metal Oxide Solutions database, TCOX14, is also available. The database adds 2 new elements, barium and lithium, bringing it to a 34-element framework. Several properties are included for these new elements. The database also adds 138 new phases, many new binary, ternary, and quaternary systems, and adds thermal conductivity and resistivity and electrical conductivity and resistivity for all the ionic liquid and solid phases. The expanded database is now relevant for glass ceramics when barium and/or lithium is included. Another application is the recovery of lithium in the pyrometallurgical processing of lithium-ion battery recycling. A new version of the Molten Salts database, TC-Salt2, is released. The database adds lithium, bringing it to a 12-element framework. The database also adds many new pseudo and mixed systems, 23 new phases, and 3 new thermophysical properties, surface tension and viscosity of the ionic liquids, and molar volume of the ionic liquids and solids. Thermo Calc 2025a also includes 4 updated databases, as listed. We hope you enjoy using Thermo Calc 2025a. You can learn more about all the new features, updates, improvements, and databases on our website at thermocalc.com/release news.